is for the, which one we use? We got A is when we are, yes, when we're doing the intervals. So we do stat test A if I want a confidence interval. And the other option is to do stats test number 5, the one proportion Z test, if I'm just doing my regular hypothesis testing. So if I'm asking you to find the p-value, the probability, we do the number 5. Sometimes we do it with the confidence interval. So those are the two options. When we are talking about the mean, what is the criteria? Greater than 30, or the population is normal. What variable do we use with this? X-bar stands for mean, but when we calculate, we're not doing the z-score, we're doing the t's. Do you remember that? We see the t statistic. So our tests, okay, we have two options. If I'm doing the confidence interval or just like our regular hypothesis testing. So if we look, stat test, if we want the confidence interval, that one is 8. And if I'm just wanting to do my hypothesis test, we do number 2. So that's kind of the hard part, remembering what to do. We're doing it all in the calculator, but if you forget your test, it's a little nerve-wracking. There's a long list. But if you know your variable, that kind of narrows it down. If I'm talking about the mean, then the only things I'm looking at on my calculator involve a t. If I'm talking about proportion, everything on my calculator involves a z. The other thing, if you pick the wrong one, you're going to know because it's going to ask you for information that you don't have. So if it's prompting you for things that aren't given in the problem, there's probably another test that we can do instead. All right, so that's kind of not on our handout, but just a good recap from the chapter before we go in. So let's take a look then. Number 1 tells us, according to the CDC, 19.6% of children are overweight. A school nurse thinks the percentage of overweight students in her district is different. Part A, identify the null and alternative hypothesis. What parameter is being tested? So if I'm talking about a percent, what is the variable I'm using? P. And the null is always what? Equal to. So for 19.6%, I would say P is equal to 0.196. The alternative, we call that H1. She just said she thinks hers is different. Not equal. So my parameter, that's just your variable. So that's the P here. Alright, so B, is this left, right, or two-tailed? Two-tailed, because not equal to. It could be less, it could be different. C, suppose the null hypothesis is rejected. What could my conclusion sentence be? So we might say, there is evidence suppose the actual percentage in her district is 19.6%. So we rejected the null. We concluded this one. Should we? Because she said, and the question now says, it actually is 19.6. So we concluded the alternative, but we were wrong. So we made an error. Which type of error is it? 1. If you conclude H1, that is type 1 error. Okay, and it's an error because we made a mistake. We rejected the null, but we should not. Give an example of the other type. So, what would type 2 error be? Right, so type 2 would be concluding the proportion is 0.196 when it is actually different. Any questions there? Number 2 is practice reading from our tables. So let's get out our tables. Part A. So we're finding the critical value. We're finding the t here. A right tail test, which if we're talking about the t, and how do I know, I guess I should say, how do I know I'm looking at a t value here? So I'm asking for that critical value and I'm talking about the mean. Anytime I'm talking about the mean, that's the t statistic. It tells us it's a right tail test, which if we look at the picture at the top, this table is right tailed. So the alpha is 0.02, so we're in the 0.02 column. And my n is 16. On this table, I need degrees of freedom. If n is 16, how many degrees of freedom do we have? 15. So I'm going to 15 degrees of freedom, so row 15, column 0.02, and what is the number on here? Everybody look to a table and let me know if you don't see that. So the column is our 0.02. Degrees of freedom is always n minus 1. So 16 minus 1 is 15. Part B wants left tail. Now this table gives us area to the right. But remember, it's symmetric around 0. So if I find the area to the right, these t values are always positive numbers. So for the left, what do we know our t value would be? Negative. So I just know that my t is a negative of whatever I see on my table. My alpha is 0.005. So go over to column 005. And 26 is the degrees of freedom. So down to row 26. So we get negative 2.779. All right, C, two-tailed test. Alpha is 0.02. So if it's two-tailed, what do we know about our t's? If alpha is 0.02, the 0.02 is split over the two ends. So how much is actually in each one? Yeah, you just do 0.02, or sorry, it was 0.2, wasn't it? 0.1. So we have 0.2 total, but we split it into two tails. So 10% in each one. What is my degrees of freedom? Any issues reading those from the table or understanding those? The next one, I said by hand, but let's just do them. We kind of have been doing all these on the calculator. I just failed to change that. We do need to make sure we are writing our null and alternative hypothesis. If it's not given, we have to check our criteria and then our conclusion, like reject or fail to reject. So on number 3, I did give you the null and alternative, so we don't have to worry about that piece. The null is that P is equal to 0.55, alternative is less than. Okay, so what criteria do I need to worry about? So my N is 150. P is 0.55. So that's greater than 10. We're good there. I didn't even give you any information about the population, so you can't really verify the less than 5%. So this is really the only one we have to check. Then, if we are doing this on our calculator, so I'm going to go to stat, test, which one? Okay, so then it's going to ask me some questions. P sub 0, what's the P of our null? That's the 0.55. X is given in the problem. It told us X was 78. N is 150. And I am testing the less than. So calculate, what I've asked, usually I write down the Z and the P. The P is technically all you need, but it is a little helpful for me if you write down some other things. If you were to get the wrong answer, that helps me kind of figure out why you got the wrong answer. But we should get a probability of 0.23. What would that tell me? What's my conclusion? Right. Is that unusual? No. We can also compare, did I give you an alpha in this problem? Okay. So the easiest option is just compare P to alpha. Remember, the alpha is 0.1. So if P is greater than alpha, you fail to reject. Okay, the only time you reject is if P is less than alpha. So if I ask for the conclusion, if I ask you to write a sentence, that's when you need to state in words, if the null hypothesis is true, there is a 23% chance of this happening. If I just ask for the conclusion in general, that's just reject or fail to reject. Did everybody get that one to work out? Researchers know the mean weight of kidneys in mice is 355.7 milligrams and normally distributed. 12 mice were exposed to PVC in their drinking water. The researchers believe this will increase the mean weight of the kidneys. So what is my null hypothesis? And we're talking about the mean, so that's mu. The alternative, what do the researchers think is going to happen? Okay. Criteria. If I'm talking about the mean, I either have to have n is bigger than 30, is this one? No, or yeah, it already tells me it's normal. So if I tell you it's normal, we're good. Because it told me the population was normally distributed. Okay. So if I want to test my hypothesis, so I go stat, test, which one? So then we have the option data or stats. Data is if I give you like a list of points, which I didn't. So we have to go to stats. The mu of the null is a 355.7. X bar, that's the mean of the sample. If we go back, what was the mean weight of their mice? And the standard deviation of their mice. And the number of mice. Okay. Again, like on a test or quiz, this is easy work. You can show me just what you're typing in for each of those values. So if you do make a mistake, I can kind of find that. We are testing greater than. So if we calculate, it tells us that the T 3.14, P is 0.0047. So what is my conclusion?
Or reject.
So alpha is 0.05. So our probability is less than alpha, which means we reject. Anytime the probability is smaller than your alpha, we reject. This going okay? Number 5. It's believed that 43% of Americans prefer Pepsi over Coke. A taste test is done with 100 individuals and 53 prefer Pepsi. Do Americans feel differently? So what would be my null hypothesis? Close. Are we talking about a mean? It's a p. When we have those percents, we're talking about a proportion. So p equals 0.43. The alternative, I'm testing to see if they feel differently. So that would be not equal. Okay, criteria. What's my n for my sample? 100. P is 0.43. 1 minus 0.43. I need that to be bigger than 10. So quick check. And that is, so we're good. So this one says construct a 95% confidence interval. So if I want the confidence interval, I'm talking about P, so that means my variable is Z, so where do we go? Alright, my X. What was X in our problem? That would be our number that preferred Pepsi, which was 53. What the N we said was 100. Sea level is 95%, so 0.95. Calculate. This means we are 95% confident the true value is between these numbers. Is my null hypothesis in that interval?
No.
That's bigger. So since 0.43 is not in the interval, what does that tell me? We're 95% sure the real answer is in here. My null hypothesis is not, so I reject it. Number 6. In 2000, 58% of females aged 15 or older lived alone. When I see that 58%, what does that tell me my variable is? Okay. A sociologist tests whether this percentage is different today. So my null is that P is so criteria in how many do we times P, which is 0.58, 1 minus 0.58, has to be bigger than 10. And quick check, is it? Okay. So then we will go where? Stat test. 5. Okay, P of the null is 0.58. X, it told me how many in their sample?
500.
So 500 is my my total, and out of those, how many lived alone?
285.
So X 285 and this 500. My testing not equal. So our P is 0.65. So, is this unusual? No. This tells me if my null hypothesis is true, there's a 65% chance of getting the sample I did. My alpha here was, so since P is greater than alpha, we fail to reject. Number 7. In 2002, the mean age. So what's my variable this time? So it tells me my mean age was 37.4. Sociologist wonders if the mean has increased, so the alternative would be criteria. If I'm talking about mean, my n has to be bigger than 30. So if I look at this, my n is 32, so I'm good. So then we go to stat test. 2. Mean of the null, 37.4. X mean of our sample. Standard deviation of the sample. The number in the sample was 32. And testing greater than. So our P is 0.03. Alpha is 0.05, so what does that tell me? Mhm. So we reached it. We have enough evidence to conclude that the mean is greater. Is it coming back? Last one. In 1990, the average concentration of calcium in precipitation in New York was 0.11 milligrams. A random sample found the following data. So, what do I have to do with this data first? Okay, all of it goes in L1. Am I talking about a mean or a proportion? The average is the mean, so the null would be that the mean was 0.11. Assume the data is normal. Does the evidence suggest concentrations have changed? So my alternative would be, so criteria, I already told you it was normal, so we don't have to worry about that. We go in stat test since it's a mean. That's number 2. This time we're basing it off data. Mean of the null is the 11 or 0.11. List should be L1, frequency is 1. We are testing not equal. P is 0.12. In the problem it told us alpha was 0.05, so what does that mean?